So we are on day 28 of this 9 weeks, in case you didn't know where we were. We're going to finish notes today. The ones that y'all should have worked on yesterday, we're going to go over. And tomorrow, well, at the end of class today, we're going to work on the data nugget a little bit, at least on the graphing part. Making sure y'all did that correctly. The graph, I think, probably had something on there that you did not know how to do, which is graphing standard error, except for Luke. Anybody else know what standard error means? Yeah, so it probably had standard error on there, and y'all didn't know how to do that, so we're going to have to go over that for the graph part. And then tomorrow we'll go through and talk about what that means and answer any questions that you had to do on there. And then also we're going to do an FRQ tomorrow. Friday will be your test on Unit 5. Unit 5 test is very large, probably 140, 150 points. This is one of the biggest units, most content. We spend about twice as much time as we have as opposed to our other units. So make sure you study. Friday morning by 8 o'clock, Trent, your progress check is due. So make sure you complete the progress check. I'll open it up today at lunch. And then you should be able to get on there and take it. As long as you get half of them correct, you'll get full credit for that. I assume if you don't get at least half of them, you probably, I don't know, went comatose or did some drugs during the test-taking quiz process. So get on there, take your time, go through, answer them. When you're through, you should be able to, Jemai, get back on there and look at the correct answers, see the ones you missed, and look at the correct answers and see why you missed them. Okay? I made it due by 8 o'clock on Friday morning. I would probably do it tonight or tomorrow night so you have time to go through and look at the ones you did wrong. But I'm probably going to be checking it while you're testing on Friday if I had to guess. But it's going to close after 8 o'clock. So get that sorted out. And then next week we'll start on Unit 8. We'll probably go through Unit 6, sorry. We'll be working on it all next week. And then the last week, I'm probably just going to designate Monday and Tuesday as review days because your test is going to be pretty big and we need to review over some concepts and terms and things. And you got a lot of material to look back through. And then the last 3 days will be test days, and we won't do anything new or weird on those days. If y'all, I don't even know what days we're testing, to be honest. But when I figure that if y'all are in here today, I mean, either we'll watch something or y'all can study for other stuff. So, any questions there? So, in part J of the notes, impacts of urbanization, page 10. Read figure 1.9 for us, Donovan.
India, the human population will continue to grow for at least 50 years. Unless humans can devise ways to live more sustainably, these population increases will put additional strains on natural systems.
All right, we've talked about populations. Where do most people live?
Asia.
Like anywhere on Earth. Where do people tend to? Okay, they tend to live in cities or surrounding suburbs. Urban is talking about cities. Suburban is the surrounding areas like what neighborhoods we have around here. Rural is out in the country. You people in Duncanville know what I'm talking about. So, yes, so post World War II, you saw kind of this mass movement of people to cities. For what purpose? Work. And everybody go to work. I won't finish that since we're on TV here. So, what is that term, urbanization? What does that mean, Jeremiah?
Make more cities, make them bigger.
Okay, yeah, cities developing, people moving there, cities getting bigger. So people are going there for work. There's a lot of activities, fun things to do in the city, more money to be made there. And so you see kind of this mass migration to cities. You also saw after this kind of urbanization, a lot of people moved to cities, but then they started moving where? Suburbs. Now, let's look here. Page we on. Turn to page 13 real quick. This talks about living sustainably at the top. In cities, we're going to discuss energy usage. A lot of people in cities drive. Some people use mass transit. More efficient ways or more environmentally friendly ways of getting around would include walking, riding a bike, riding. I know Atlanta now has a bunch of those little scooters, like the Razor scooters people used to ride, or like kids, some kids have, or maybe y'all have some. They have like big adult ones that are battery powered, and I think you just there's an app or a credit card you can put in, and you can grab one of those bikes and ride it somewhere, and then you just leave it when you're done. And then I guess somebody comes around and gets them and charges them every now and then when they need charging.
That bird thing?
Do what?
Bird?
I'm not sure what it's called. But anyway, those are some more environmentally friendly methods of getting people around without everyone having to drive cars and getting to where they're going. Mass transit also kind of serves that purpose. Mass transit is what, Colby?
Just in terms of people going together, like on a bus or anything.
Okay, buses, trains, subway, things like that help you get around, but you're riding with a bunch of other people. The benefit of mass transit is what, Jason?
Well, it's a benefit because you're not taking like 50 people driving 50 different cars. They can all just get on a bus somewhere.
Yeah, so if you think of 50 people driving 50 different cars, that's a lot of cars. It's a lot more gas than like you could have on one bus. In the age of COVID, I don't know. I'm sure mass transit. Well, I don't. New York City for a while they were still running their subways wide open, and some people attributed that to kind of that mass explosion of COVID in COVID early on, where a lot of people got sick and died in New York because they were they'd shut down almost everything else, but they had the subway still going, and so I don't know if now they've kind of spaced out where people can sit, and a lot of subways you see people just all packed in super tight together. Especially in a lot of foreign countries, where they'll just be packed in tight as a tater, and I'm sure that's not good if you're talking about people spreading infectious diseases to one another. So that is something to consider, but it definitely, environmentally speaking, it's much more sustainable because you don't have to have as many cars going from place to place. So, and a lot of people, in New York City, walk places. I know it's kind of mind-blowing for us to think, DeQuinte, about walking somewhere. Can you imagine living in a city where you could just walk to all the places you normally go to? Like restaurant, whatever. When we were, me and this other teacher one time used to work downstairs in the history department. We went on a backpacking trip to Europe. And we were in Austria. And we just flown in. We spent a day there walking around looking at stuff, and we were trying to get to the train station to go to somewhere like Vienna or somewhere. And so we asked this old lady on the sidewalk. We're like, "Where's the train station?" And she's like, "Just right down there." And we're like, "Do we need to take a bus or can we just walk there?" She's like, "No, just walk, just walk." It was probably a mile away. Which doesn't seem that far, but it took a while to walk through a city. And so just for her, this older elderly lady to say, just walk there and not think it was a big deal, really made me realize that, most people there, that's what they do. They walk to get wherever they're going. And even if it takes a 20-minute walk, to get somewhere, then that's not that big a deal to them. And a lot of people in a lot of places, that's what they do. They walk places. For us, that's not really, sustainable here. Why? Yeah. Yeah, most people do. And the subway's pretty cheap if you're going a longer distance. Cab's really expensive. Buses, I don't know about their bus system. I know in Atlanta they've got a pretty good bus system with MARTA. You familiar with that one? I've rode MARTA going a couple times going to the airport, but around here we have the trolley. I don't even know if the trolley even run out to Shelton and Publix and stuff anymore. It still does? I haven't seen it in a long time. Maybe I just haven't been out as much, but I know it used to.
It's not really that often.
Does it run a couple times a day?
Yeah.
Bigger cities, they have where buses, they're running on the hour, every couple hours, and usually they're pretty consistent. So it's a good way to get around if you don't have enough money. or you can't drive a car or something like that. And so it's also cheaper because you don't have to have, to pay for a car, pay for insurance and all this kind of thing, and pay for a parking spot. Like my brother-in-law lives in San Francisco, and to pay for just like a place to park, maybe as much as like a lot of people pay for an apartment around here, like $600, $700, $800 a month, just to have somewhere to park your vehicle. So it does help reduce the stress on cities when people use different means to get around. It reduces fossil fuel usage because the less cars you have, the less fossil fuels, diesel, gasoline you're going to burn. Now, you can kind of oppose that with a city like Los Angeles that's really spread out. Almost everybody drives a car. You ever see those pictures of the Los Angeles freeway where there's like 10 or 12 lanes wide and they're always full, like going in and out of town?
10 or 12 lanes?
Yeah, it's huge. And like it reminds me of like Atlanta. Like Atlanta, usually they'll have like 6 or 7 lanes on 285 and going through most of the city. I'm gonna be honest, I hate Atlanta. My in-laws live there. We go over there and see them, but driving around Atlanta is like a total nightmare for me. I don't like 5,000 people right around you, and they all drive like crazy, seems like. But anyway, do what?
So it makes you feel unsafe.
Yeah, a little claustrophobic on the freeway. But there's a lot of people, and they drive a lot of places. It causes a lot of smog. So, because they're using a lot of fossil fuels, and there's a lot of stuff getting in the atmosphere. We'll talk more about that when we get into the air pollution unit a little bit later. All right, let's see what else here. Resource depletion. When a lot of people live in a small area, what does it take? Where do those resources come from? What? Surrounding areas, yes. Because most of those resources aren't going to be mined or grown or wherever in the city. You may have a community park. You may have a small little garden on your rooftop apartment, Colby. But for the most part, most of those resources are coming in from the surrounding areas. And so that's a big strain on the areas outside the city. I would not want to live in a city in a time of desperation. Like even during Corona recently, we see all the problems with like lockdowns, and there's trouble getting stuff in and out. I mean, like there's even trouble getting like toilet paper around here sometimes, which is another story I don't want to get into. But anyway, can you imagine living in a big city with millions of other people and they're all trying to get the same amount of resources? I mean, and like you have not as many people coming in and out bringing those. That's a difficult, kind of scary situation to be in. So lots of resources have to come in from the outside. Saltwater intrusion, 239. All right, we talked a little bit about this when we discussed aquifers and water usage. Most cities around the world, most people around the world live close to where? Yeah, they live close to the coast. I want to say it's, y'all can fact check me, I don't know if it's exactly right. I think it's about 40% of people live within roughly like 50 to 100 miles of the coast. I want to say it's probably 50. So if you think about in the U.S., like we kind of go around the country, Mobile, New Orleans, Houston, L.A., San Francisco, San Diego, Portland, Seattle, New York, Philadelphia, Washington, Baltimore, Jacksonville, Fort Lauderdale, Miami, Tampa. I guess that went all the way around. Anchorage, Honolulu, or really anywhere in Hawaii. Most people or a lot of people are living, a very large portion of the population is living close to the coast. So it was historically easy to transport, get stuff in and out. A lot of people like the beach, a lot of people like the ocean. So anyway, a lot of people live close to the coast. Now, a lot of times there are rivers close to where people live. Like in Mobile, you've got the Alabama River that comes down through there. What do you think the river's like in terms of water quality by the time it gets to Mobile? It's probably got all the pollutants that have been washed into every part of Alabama almost and washed down to that point. So I would say the water would make me a little nervous to drink. Now, we have pretty good ways of cleaning our drinking water. So it's probably not a big issue for us in developed countries. But if you lived in a poor country, by the time the river gets close to the ocean, if you're pulling water out of that river, you probably dealing with some dirty water. So what would be a good way to get clean water? Well, yeah, groundwater, because the ground does what? Filters the water. The problem if you're close to the coast and you're pulling a lot of water out of the ground is this problem called saltwater intrusion. It's at the bottom of 239. Where normally fresh water is inland, it's constantly flowing either on top of the ground or underground toward the ocean and out. If you pull enough of that fresh water out, though, that salt water from the ocean is going to start to seep in. That's where the saltwater intrusion is. And if it does so, it can ruin a well. If you're using that for farms, it can ruin the land. So that is an issue that happens in some places there close to coast, like you see on 239. All right, next thing, impacts on carbon cycle. We already talked about living in cities requires lots of fossil fuels. What has been the problem you've had the last couple mornings?
Cold.
Been cold as a tater. Now, when it's this cold, what do you need?
Jacket.
Lots of heat. Good. I imagine all of y'all have had your heaters on at home. How do you set your heaters?
70.
My dad is.
All the way.
My uncle is the same, and he won't put it on. So
What is it usually on?
68.
Oh, that's pretty high.
It was at 62 this morning. I was like, doesn't make sense for it to be cold outside.
Okay, so when I get home, my nana like automatically has it like on cool. Like she doesn't even have the heat on. I don't know.
She just
why.
turns it off.
Yeah.
Probably because she has to pay the power bill, right?
Yeah.
I know y'all don't have to think about this at this point in your lives, but someone has to pay the power bill. And if you're talking about the difference between 70 and when it's 20 degrees out all night, that's 50 degrees that you have to keep the temperature above the outside. And depending on how well insulated your home is, how old it is, how good your windows and stuff are, like that could be a lot of energy that it requires, which means a lot of money. Like at night, I'm like you, I probably got mine, gosh, what is it on? I'll usually set mine on about 63 at night because I don't want my kids to freeze to death. But I just tell them to pretend like they're camping. And usually, like in the morning when we get up, we turn up the heat to maybe like 68 or 70, depending on how freezing my wife is. But you're under covers. I mean, why do you need it that hot in the?
Well, sometimes I don't want to get out of bed, not because I'm tired, but because I know it's going to be like a very large gust of cold air that's going to hit.
Yeah.
I won't
That's
get
why
out
I
of
don't want to
bed.
get out of bed.
I won't do it. I won't get out of bed. It's bad. I have to have it warm, or like I'm gonna be late to school.
I have like two comforters in my bed because I get cold.
I wonder what people did back in the day before central heating and air.
Get hypothermia.
My father, they grew up and like when he was really young, they didn't have electricity for the first few years, like until he was 6 or 7, I think. But they really only had like one like fireplace in their home. Fireplaces are historically inefficient because most of the heat actually goes up and out, like 90% of it, because hot air rises. And so if you've got a fireplace with a big open shaft, most of that heat's going to go up and out. And wood heaters are different because they kind of radiate that heat from the metal and the wood box or whatever it's made out of. But fireplaces aren't very good. And so he was like, yeah, we would sleep with like 5 quilts on top of us to keep from freezing when it was cold out. And so now imagine that you live up north somewhere. I mean, there's a lot of people live up north in cities. It's going to require a lot of energy in order to keep you warm, especially if you're talking about like an older person. I mean, it's one thing for our young, healthy bodies to produce lots of heat when you're cold or chilled. And we think like, 62 in the house is cold. I was telling my wife last night, I was like, it's like 63 in here. And I was like, but when it's 63 outside, it feels pretty good. When it's 62 or 3 in your house, it feels like you're freezing, Anyway, so in order to heat homes, it requires lots and lots of energy. And most homes use what to heat them? What kind of heater? Quinte, wake up.
Gas.
Okay, usually either electric or gasoline. Or not gasoline, methane around here. And then up north, they use a lot of heating oil, which is kind of derived from petroleum. And so it requires lots and lots of energy. Lots of fossil fuels. Landfills. Turn to 273. Actually, hold on a second. Turn to 194 first. Big cities make lots of what? Trash. Good. So in Tuscaloosa, you know those little green cans that y'all put out on the side of the road with your trash in them that you fill up every week? Where does that trash go?
Landfill?
Landfill.
Where is the landfill in Tuscaloosa that it goes to?
Never seen it.
Never been.
Now, y'all probably have seen the landfill around here. If you turn by Mapco and McDonald's over there, and you cut down Bear Creek Cutoff, you know, before it splits there, you can see like a big hump of red dirt on the opposing hill. If you've never looked that far, then go down through there. Turn by McDonald's, go down through Bear Creek, and before it kind of splits off, if you look on the hill, like on the other side of like where 82 is, you'll see like a red mound of dirt. That is the Duncanville landfill. It's over there back behind, Jason, where like Dreamland and all that stuff is. And Coca-Cola plant and stuff off 82, 4 places behind there. Yeah.
When my mom lived back in Vietnam, they lived in a H-straw hut-like house on a white sand beach. And
They lived on the beach in the straw hut.
Yeah.
That sounds pretty sweet.
It's really small. It's like as small as that closet.
It's okay.
So for temperature wise, it's always hot because they're in the tropic area.
Mhm.
Tropic area. So for cooling, they always have they use a natural wind for the cooling.
Yeah, so a lot of big cities, especially up north or like throughout Europe, they're not going to have air conditioning. They just use like natural airflow. Air conditioning is really kind of a U.S. thing, and especially like in the southern U.S. Where it's hot. A lot of places they do not, even in the tropics. You're right. So, and usually the farther north you are, the less hot it is in the summertime. So it's not as bad of an issue. Okay, where are we going with that? Oh, on 195 at the bottom. This gives you some of the larger cities in the world. Now, these are talking about the metro area, so not just the actual city of Tokyo or New York, but the surrounding suburbs and little cities that surround it that feed into it. Like Atlanta, for instance, I want to say the city of Atlanta only has maybe 600,000-700,000 people in the actual city of Atlanta, but the Atlanta metro area with all the little cities around it's about 4.5 million. Which is roughly the population of the state of Alabama. So a very large metropolitan area. In New York, that New Jersey area that feeds into, and all of New York City, there's about 20 million people. That's about how many people there are in like the entire state of Florida. So that's a lot of people, and a lot of people produce lots of trash. Where does that trash go?
The ocean.
We're going to learn about in Southeast Asia, a lot of trash does go in the ocean. In most developed countries, it usually goes to either landfills. Like New York City, for instance, had an island that they filled up. They actually filled it all the way to the top. It was their own landfill island. I can't remember the name of it. And it filled up, I want to say, maybe 10 years ago or so. And then they had to start shipping their waste elsewhere. Like they were shipping some of their waste on train cars to South Carolina. That's how far they were having to ship it to try to get rid of it. Massive train cars filled with just trash. A lot of cities in Europe, they take a different route. They incinerate their waste. Now, incinerating waste is beneficial because you reduce your waste dramatically. You're only left with like a few % of what you originally had. The problem with incinerating is what?
The ash is in the air.
Yeah, so you've got a little bit of air pollution. Now, they're pretty good about like having filters and scrubbers and stuff, but there is a little bit more air pollution. When you burn something, you're going to release CO2. But now think about this if you're doing your cost benefit, Trent. When we carry and put our trash in the landfill, what's released there? What's broken down? What's made by the breakdown of trash? Because most of your trash is paper and plastic. huge amounts of methane. And in fact, the one over in, okay, so all of our trash in your green bins goes out to Coker. If you go past the Walmart on the right, like going toward Lake Lurleen a couple miles, you'll see it's a waste management. They got like a gate up. It says landfill, Coker landfill or something like that. Anyway, that's where all our trash goes. We did a field trip out there one year, and we'd probably go again, but they've put a hiatus on all my field trips this year. Where was I saying? Oh, so it's a lot of trash. When they cover it up, that waste breaks down and it releases methane. Methane is a much worse greenhouse gas than CO2. So do you know what they do with the methane they collect?
Turn it into fuel.
That would make a lot of sense, but no, they burn it. They burn it because it's much better for the environment to burn it and release CO2 than it is to release methane directly in the environment. I said, why don't you just like burn it and use it for energy? And they said, you've got to have some way of like compressing it and getting all of the water and other stuff off of there. And I think maybe just they didn't have enough money for the infrastructure for that. Although it seemed like that would be a good plan for like the city to invest in if they had free methane. But they didn't ask me what to do. Anyway, so fossil fuels, a lot of fossil fuels go into cities and they produce lots of trash. Now, you guys talked about impervious structures. Turn over to page 2. Yeah.
Have you watched or heard anything about like Singapore and what they do in Singapore?
No, what do they do?
So because Singapore is like such a small island, there's a video I can send you about it. They take all of this trash and they burn it in this facility, and it filters. They spent the money on transferring the methane and the CO2. They filter it and they release it in some other gas form that's better for the environment. And then they take all of the ash and they like do something with the ash, but then they put it in the coral reefs and it promotes coral reef growth.
Well, like I know in the European cities where they incinerate, they're using it for that energy to produce electricity. A lot of times if it's close to a city, they'll use it to heat buildings and stuff. So they're getting benefits out of it, and it requires a lot less space. So I think maybe in the future that may be something a lot of larger cities in the U.S. have to go to, assuming they get the the air pollution issue sorted out. Yeah.
Did you know that in Japan they have like a calculator club?
A calculator club? Donovan, you're throwing out some random stuff today, buddy. Let's stay on task. All right. So impervious structures. Yesterday you had to come up with a way, design an experiment to mitigate urban runoff.
What page?
273, sorry. Yeah, so I'm going to get to, you can just go ahead and turn to this. We'll get to it in a second. Impervious structures lead to flooding. Impervious structures in a city would be what? What? Tall buildings? Is that what you said? Yes, buildings. What else? Roads, anything made out of concrete or asphalt. Most cities are impervious structures, which means rain that falls on them that would normally have soaked into the ground is running off. And it's running off directly into like a storm drain or storm sewer, which is going into a river or stream. And so two things, causes flooding, and lots of water also means lots of erosion. And I'll give you an example around here. You know the ditch in front of Chick-fil-A? Everybody familiar with that? So that's like a normal stream. If you go back up there behind like Walmart, you can see how it kind of looks like a stream, like you would find out in the woods back in the day. Or if you go that road by Pfeiffer Wire where Pico is, you can see where it comes out the other side. It just looks like a normal stream you would see in the woods. But it's been so developed right there. Basically, they've killed all the grass and animals and stuff that would have been in and around the creek. Anyway, sometimes that river, that creek or that ditch, whatever you want to call it right there, floods. Like when it rains a lot. What color does it look like? Brown. Usually it's brown and a lot of sediment. Where does the water come from for that stream? Well, I mean, but where's the rain land?
On the building.
Where does it start? Starts up at Walmart, Sam's, McFarland Mall, Woods and Water, all those areas up there that are like impervious, like thrift store, all those parking lots, it runs directly off into that stream. And then it runs down through there. And then as more water there is, it's going to chip away at the sides of the stream and take what with it? Dirt. So that's the issue, flooding, sedimentation. Now, let's say that all of those parking lots had been paved with infrastructure for impervious or permeable pavement, what would that do?
Decrease the water going into the.
Yeah, it would increase water soaking into the soil and recharging the aquifer underneath, and reduce the amount of what? Erosion and flooding. So it's more expensive, but we also have to think about like what are the environmental costs, what are the costs of the people that live downstream, okay? Because a lot of places where it floods, like it will flood downstream and like people die. Like we talked about in India and in Bangladesh, how it floods in India, or there's a lot of rain in India and then it winds up flooding downstream and killing people in Bangladesh. All right, depletes the groundwater because the groundwater cannot recharge because there's no water coming into it. The next topic here, urban sprawl leads to a depletion of rural lands like forest and farmland. So in 273, what's happened since the 1950s?
It started to go down.
We are going to the suburbs and less rural.
Yes. So people in cities has increased slightly. Rurals went down. And most people that were born in population increase since the 50s has went to suburban areas. There's almost as many people in the suburbs as there may be, hold on a second, you're pretty close. There's almost as many people in the suburbs as there are urban and rural areas combined. So like where you see neighborhoods out here, that's the suburbs. Now, I'm not bad-mouthing suburbs, okay? But there's some environmental issues that suburbs create. Let's say Hinton Place. Hinton Place used to be a what?
Dairy farm.
Dairy farm. Y'all seen the dairy cow in the middle of it, the statue? You might. Yeah. Okay. So most of y'all, if y'all have never driven through there, if you drive through there, you'll see a big statue of a dairy cow. And there's an old wooden log cabin there. I think that was one of the original like home places that they had. I think you can actually rent it out and stay there, can't you?
Yeah, you can.
Anyways, that used to be a farm. Now it's a what? It's a neighborhood. What about Fields Crossing over here? Used to be a what? You know what I'm talking about?
Yeah.
Fields Crossing down on Marion?
Yes.
Is he asleep?
I used to live there.
Quinte! Get your life together and wake up. Fields Crossing used to be a farm. I know an older guy that lives down the road, and he's like, yeah, I remember when that was a cow pasture. So, and then most of these neighborhoods across the street, like I used to live in Remington over here, most of these neighborhoods across the street are pretty new in the last 30 or 40 years. That land used to be what if it wasn't farmland? Forest. So as people spread out from cities, they're basically taking away forest habitat, or they're taking up good farmland that was used to grow stuff. So as cities get bigger, you have less and less food that you're able to grow. That's an issue. Yeah.
I'm not meaning to sound like, I don't know, rude when I say this, but like, if the suburbs, like, how, if they're right next to each other, but wouldn't you take up land if you're in a rural area anyways, like?
So like you're saying, as opposed to people living in rural areas, wouldn't you
Yeah.
take up land too?
Like, why is that worse? Because.
I think it would be opposed to us living in a city. Because in a city, if you skip over to, that's a good question. Because you're taking up land either way. So, riddle me this, Smelly. Why do people live, skip over to part M, why do people live in the suburbs?
More house, less money.
Cheap.
More house, less money, it's close to jobs, you got a bigger yard,
Yeah, the city.
people like the neighborhoods better. What? Usually less crime. Less pollution associated with cities. Now, one thing that you do have is it's just at the end of Part J, increased travel time and fuel. So if you're, and I know some of y'all probably live down toward like Moundville. Maybe you live in a suburb down there. I know a couple people, y'all know what I'm talking about, like down Big Sandy and those areas. So if you live there and you're traveling into the city, or you're traveling like out to Mercedes to work, or you're coming to school here, then that's increased travel time, and you're still living in the suburb. Now, I'm not bad-mouthing where anybody lives. I know you're all a product of wherever your family has to live. But ideally, if you're talking about reducing your fuel use and reducing your impact on the environment, where would you live?
In the suburbs?
The cities, because I can walk and use my transport.
Well, okay, I'll say this. You would live close to where you work and or go to school, right? Where you work, because when you have kids one day, then they're going to go to school whatever's closest by. So it could be in the city, it could be a suburb. Even in rural areas, it could be closer to there. Now, I'm not saying advocating everybody move away from rural areas or everybody not live out in the suburbs outside of city. I'm just saying that's something you have to consider because you're increasing the usage of those resources in doing so. And like Smelly said, well, let's just say we took everybody in the suburbs and spread them all out in the country. Wouldn't it take up the same amount of land? The houses would take up the same amount of land, but you got to think about a lot of people live out in the country. They'll clear out a little spot for a house and they still leave the forest around them, or they still have a garden around them. Like, how many people do you know in most of the suburbs around here that still have a bunch of trees around their home or they have a garden around their home? Some people do, but not many. And most of the time what happens with the suburbs, which I hate, is they clear off all the trees, so it makes it a lot harder, so you have to use a lot more energy. And they clear off all the dirt, good dirt, so you couldn't grow anything if you wanted to. So those are some of the issues that makes it more difficult. Like if people live in the suburbs and they grew like their own backyard garden and, you know, they live close to a school, and like I've had plenty of students who walked to school or rode a bike over to school before. Like that would have a minimal impact on the environment.
Marco walks to school.
Does he?
Yep.
I was looking for him. I forgot Marco's in first period. Yeah.
Where my dad lives, we live near downtown. My brother was at a state mountain school, and my dad walks to work.
Yeah.
And my stepmom just.
When you see that in a lot of big cities, like people either ride to work or ride a bike to work or walk where they're going. I used to have a student who lived like across 69 over there, and he would ride his bicycle all the way here. I'm surprised he getting run over out there. Anyway, yeah, Andrew.
Next to Murphy's Christmas Tree Farm, like that neighborhood that
Mhm.
line, that used to be like the entire farm, but then he sold the land, so now it's neighborhood.
Yeah. I know that guy pretty well. Yeah, so that was. So I mean, like, people need places to live, people need homes, but we also have to think about like what are we giving away. Now you could think of it like this, Andrew. There's a lot of neighborhoods around here where we've got this bad habit of people move into a neighborhood. It's nice, it's new. A lot of people move there, and then they start moving out when other new neighborhoods form, and then they kind of leave that one, and it deteriorates, and it gets worse and worse. You see the same thing in cities, where people move out of a part of town that's older and that hasn't been money put into it for a long time, and then people move away, and then those areas just get decrepit and run down, and they spread out other places instead of investing in those areas to revitalize them. And so a lot of that kind of spreading and movement happens, you know, as people are just building new things and going from place to place. Okay, what's the next thing? Methods to reduce runoff. We talked about permeable pavement, plant more trees. One thing I do like about Atlanta, they have a lot of greenways, meaning they have a lot of places where there are trees and there's forest and stuff left. Forest, where would you ideally, if you had a city and you were developing it, Jason, where would you want to plant trees? On the outside? Why not the inside? Why not all over? What would be the best place to reduce flooding, though? Next to any rivers or streams. Good. Because any forest that you have there is going to act as a buffer. Good. Mass transit helps. The more people that are in mass transit, the less what you need. Well, I mean, think of in terms of runoff. Well, yeah, and the fossil fuel and all that's true. But what about in terms of urban runoff? Does mass transit help? Maybe you said it. What did you say? More mass transit, the less cars you have. Less cars, you need less. We're thinking about flooding here. Roads, yeah. So you need.
I was thinking that, but I was like, wait.
Okay, I was trying to lead you there anyway.
But wouldn't the mass transit require roads?
Well, but a lot of people travel it. So like if you're talking about like an L train or a subway or something like that, like it only usually requires like 1 or 2 roadways.
You know those things in Disney World?
Yes,
We
just
should
like
do
that. Do what?
We should have that.
Just think like the things at Disney World carry all the people in and out that they need to, right? But if you've seen the lanes that go into Disney World, there's like 20 lanes going into Disney World. But everybody can fit on that small mass transit and move in and out.
And it's like above ground, so
Mhm.
you could probably.
So that's what, like, when you hear the term L train, that's referring to an elevated train, like in Incredibles. So it's not like an L, like the letter L. It's talking about it's elevated off the ground, so you can still have roads and other stuff underneath it.
Yeah, you know the trains at the Atlanta airport?
Yeah, that's part of the MARTA system. It comes in and out. Yeah, they're
You are on the A train. That is my favorite feeling, just being on an A train. Anyway.
all right. What else we got? Build up, not out. So the idea of build up, not out is if you build up and not out, you're reducing what? Land usage. So the population's only going to get bigger. So these are things we need to consider. Now, you should be finished with all your notes. Hopefully. If not, you need to see me. Or see a friend and get what you missed. Look at the lab real quick. So this lab is on biofuel usage. We talked a lot about growing stuff. It also kind of feeds into the next unit on what type of fuels we use. Except for Luke in here, I don't think anybody in here knows what standard error is, though. So when you're graphing this, we need to look at this. I don't think you're going to have to graph anything on the AP exam. That's the word around the campfire that I've heard on the Facebook group. But I would suspect you're definitely going to have to do some graph interpretation. So we're going to do this and make sure you understand what's going on. Yeah, should be one up there. Mm-hmm. You people on the internet, you three out there watching this, it should be on day 27 of Schoology. All right, so today's 28, but the data nugget is going to be on day 27 yet. All right, so what they're showing here is our number one biofuel that we grow is what? Corn. So we're getting ethanol from corn. Corn, though, you have to plant it every year. You have to plow. You have to till. You have to whatever you have to do. I mean, you could do no till, but you still have to go through and plant it, and you have to fertilize and all this stuff. Replenish the root structure, blah, blah, blah. What if we had a perennial that just came back year after year and you just had to go through and harvest?
That would be nice.
That'd be super. So they did a study here with some different perennials, and they compared it to corn. And they did it in 2 different states, Wisconsin and Michigan. And they're seeing how much biomass they produce, okay? So, what is our independent variable in this scenario, Caleb? Independent variable, same as manipulated, the thing that's done differently. Thing we're looking at. Jordan? The crops. So the crops are our independent variable, and then the dependent variable, Jemai, is going to be what? Yeah, so how much they grew, the biomass. Good. So where are we going to put our crops, Donovan? On what axes? X-axis, good. So remember, dry mix time, the independent variable goes on the X, and the dependent variable go on the... So you've got 6 different columns here, Jason. How many bars should we have? No. 12. Why do we need 12? Yeah, we got one for each state in there. Yeah, so you'll have like the 6 different crops, and then you'll have a bar for each state. So let like Wisconsin and Michigan be 2 different colors if you can. All right, and then, so you're just going to make a pretty simple bar graph here. Now, here's the not so simple part. All right, I've got some really hard data up here on the board. Let's say Caleb made a 70 on each 3 of his last tests. And let's say Jeremiah made a 60, a 70, and an 80 on his last test. And I said, here's what they made. I want y'all to average that and graph it. Now, when you graphed it, what would you do? And so, what kind of graph would you have? Bar graph. And then what? If you graphed them both, what would they look like?
Each of them will be 70.
They look the same.
Yeah.
So you wouldn't know anything about their data. Does that make sense? So you wouldn't know that like he was averaging all these, they were all pretty close together, and this one was like a very, very different. So one way to get around that is to graph the standard error along with that. Standard error means the difference, like how far away the data is from the average. Okay? So since this one was all the same, the standard error wouldn't be anything, it'd be 0. But this one, because that data is far away from what the average is, you would have a standard error bar above and below it. And basically, the farther they are away from the average, that means the more wide the data is. Okay? So the closer the data is to the average, it's going to be really small. The data, if it's really far away from the average, it's going to be really big. Okay? So what you guys are going to do is you're going to graph the standard error, and that should give you some indication. Now, there are other implications that we'll go over tomorrow about what, when you're talking about statistical analysis, but we'll do that tomorrow. I just want y'all to get the graph down today. So for instance, if you look at the corn, shut it. All right, corn in Wisconsin, what's the average? So when you make your bar, 16.1. But I want you to graph the standard error. And now, Luke, we're just going to do like one standard error. We're not going to do the 2, okay? So, what? You know, we used to do plus or minus 2. We're just doing 1. So when you graph that, you're going to add 0.6 since that's the standard error. So you'd have this little standard error bar that goes up to 16.7 and then also goes down to 15.5. So that's showing you kind of the variation around the average. Does that make sense?
Yeah.
So you're going to do that for each one of your bars. You're going to put one of these standard error bars in there.
And each state, like both the states.
Yes. So you'll have 12 bars, and you'll have a bar graph, and then you'll have the standard error bars to go with it. Tomorrow we'll spend a little time talking about what that means, and then answering the questions. Okay.
So that bar right there, the bar is like a 7, like the average, and then the standard error is like going up to 70, and going up to 80.
No. The formula for standard error is like some square root. You got to find the standard deviation.
Like it's what it's saying. Like the bar is like represents the average, and then that.
Yeah, so the bar represents the average, and then these represent like how far away from the average the numbers are within the data.
Okay.
So it tells you a little bit of a story about the data. Like it tells you, well, all of these test scores must have been right together, but those test scores must have been all over the place. So you can get that from looking at the bar. Whereas if you just looked at 2 bars, you'd be like, well, they're just making 70s the whole time. Yeah,
How'd you get the 15 on the?
just subtracted the 0.6. Yeah, so you're doing plus and then minus whatever the standard error is. Okay? So by the time you get in here tomorrow, I want you to have it graphed out. And like I said, then we'll spend some time tomorrow on answering the questions.